Morning all. Today we are going to discuss about the testing of hypothesis. Here in this session, in previous session, last to last session, we were discussing about the sampling techniques. We were discussed the four different random sampling, stratified sampling, sequential sampling, as well as a cluster sampling. In all the sample, as we mentioned, most of the cases we are not going to deal with the population. We are going to deal with the sample data. What we said, we are going to randomly we took the sample. The sample should not be the bias. And one more thing we will discuss, let's say if I divide the two samples, any variable average should be nearby each other, then we can say it is a correct one. But how do you know whether you're taking a sample is correct or wrong? As a data scientist, sometimes you need to look for the assumptions. You need to go for the assumption. How do you make an assumption? How sure are about your assumption is correct or wrong? Let's say if you are going with the, let's say one of your friend is birthday. Assume that one of your friend is birthday. You would like to order a cake. You went to a cake shop, and you would like to buy a cake. What kind of cake will you buy? Whatever the cake you would like it, in terms of the taste, as well as in terms of the color, as well as the shape of the cake, like attractive, then you can able to like the. Suppose you would like to taste the cake, whether it is good or not. If the cake is good, obviously then only you will buy the cake. Let's say you would like to purchase a half kg cake. Are you going to eat how do you check it whether the cake is good or wrong? Will you eat all the entire half kg cake and then you say that cake is good? Or you just check the 100 grams of the cake and you check cake is good? Will you recommend the product? Or you just check the 100 milligrams of the cake, and if the cake taste is good, then you would recommend the product. If the taste of the product is not good, will you recommend the product? No. Simply what we are doing here, based on the sample, whatever the sample we are taking, based on if you like that sample, means here in this case, cake sample means a piece of the cake. If you like the taste of the piece of the cake, then only what will you do? You will recommend the product. If the piece of the cake product taste is not good, will you recommend the product to buy the cake? No, definitely you are going to not the. So that means, are you dependent about the population or are you depending on about the sample? We are just depending on the sample. We are not depending on the population in this case. Okay, let me give you another example. Here in this case, let's say one store manager claims that, like store means our estate manager, they're mainly produced into the apple and oranges. He would like to send the 10,000 oranges, 10,000 apples in a truck. Now he would like to check whether he was able to send the correct number of cakes, or correct number of oranges. Or now he claimed that 10,000 oranges as well as 10,000 apples. Are we able to count 10,000 apples and 10,000 oranges? If you are able to count, how much time it will take? It will take some huge amount of the time. For that, what will it do? Randomly I check the 100 oranges, 100 apples. If proportion means randomly I pick the 100 apples and 100 oranges. If we are able to get it properly, then we can say that whether oranges are proportionate to the apple proportion. What if you got the out of 200, 170 or 180 apples and 20 oranges? Would you say that oranges and apples proportion are equal? No. When will you say? If both are the same proportionate count, then only we can say that, we can claim that oranges and apples are having the equal proportion. What if, let's say apples are 120 and oranges are 80? Will you claim that both are the equal? No. 30, I mean 60, 40 kind of things we can think of. That is the meaning. So always we need to classify whether it is correct or wrong. We need to check our sample is correct or wrong. Hypothesis means assuming or claiming something is right or wrong. Hypothesis means here something right or wrong. Now let me go with the one example. How do we use the testing of hypothesis? Here testing of hypothesis are two types, null hypothesis as well as a alternate hypothesis. Testing of hypothesis are two types. One is the null hypothesis, alternative hypothesis. Testing of hypothesis are two types, null hypothesis as well as alternative hypothesis. Null hypothesis, what do you mean by null hypothesis and what do you mean by alternate hypothesis? Then we will go with the example. Null hypothesis and alternate. Your assumptions and sample results are correct, then we can say that null hypothesis is true, or your assumption and sample results are not correct, then we can say that alternative hypothesis. Your assumptions and sample results, then we can say it is your assumptions and sample results are not correct, then we can say it is an alternative hypothesis. Now here in this case, let me go with the example of null hypothesis. So based on that we will come up with a discussion what will happen, right? Let's say PNB, Punjab National Bank, which is the famous now. PNB CEO claims that on an average employee age is 40. So out of 1 lakh employees, PNB CEO claims that on an average employee age is 40 out of 1 lakh employees. Now we would like to check whether PNB CEO assumptions are correct or wrong. Now how do we do? So here 1 lakh employees, does the 1 lakh employees is a sample or a population? 1 lakh employees is a population, it is not a sample. Are we able to count each and every employee's salary, each and every employee age and average age of all 1 lakh employees? Then we can say that yes, CEO is said correct or wrong. It is not possible to check all the 1 lakh employees to us. What we are going to do? We have to check the sample data. We have to take the sample data. If whatever the sample we have taken, whether the sample average age is equal to if it is equal to the 40, then we can say that hypothesis is true. That is called as the null hypothesis. If it is not correct, then we can call as the alternative hypothesis. It is called as alternative hypothesis. How do we check? Let me repeat, sir. PNB CEO claims that on an average employee's age is 40 out of 1 lakh employees. Now as a data scientist, we would like to check the CEO assumption. What is the assumption here? Age is 40, on an average is 40, that is the assumption. Now as a data scientist, we would like to check whether this assumption means employees on an average is 40 is correct or wrong. We need to prove it. For that we are going to use the testing of hypothesis. How do we prove? If the assumption, we are not going to deal with the population, we are going to deal with the only random sampling. We are going to deal with the only random sampling. Okay. If the sample results is exactly equal to the assumption result. Assumption result means on an average employee age, that is 40. If it is correct, that is called as the null hypothesis. Otherwise, it is called as the alternative hypothesis. Now we would like to check. How do we check? Is everyone is clear? We are just taking the sample 500, calculating the age, and we got the, if we got the 40, then we say that it is correct. That is called as the null hypothesis. Then we got the 40. That is called as the null hypothesis. PNB CEO 40, as he claims that 40 out of 1 lakh employees. So here out of 1 lakh employees, we are taking 500 sample, random sample, 500 random. In this case, null hypothesis, that is true. What do you mean null hypothesis? Your assumption and sample results are correct, then it is called as the null hypothesis. For example, be CEO same with the 40, that is the on an average 1 lakh employees. We are taking the salary of 500 and calculating the age, we got the 45 or 40. Then your assumption and sample is not correct, right? Your assumption, this is the rejecting the null hypothesis. Rejecting the null hypothesis. Rejecting the null hypothesis. Of course, rejecting the null hypothesis, that is called as the alternative. Maybe what could be the reason why it is not the exact correct? Maybe due to randomness in the sample or data. Because randomly we are selecting the data, maybe random, because maybe randomness means because of the random sampling, that could be a reason. It may not be the correct one. Okay, here sample size is, how much sample we have taken? 500 sample. If the sample size is greater than 30, what it could be? Normal distribution. If the sample size is greater than 30, what it could be a possibility? Normal distribution. As we discussed, the sample size is greater than 30 records, it could follow the normal distribution. How does the normal distribution looks like? Normal distribution looks like bell-shaped curve. Half of the left side will be equal to half of the right side. Symmetrical around its mean value or median value or mode value. So can we represent the same thing in the normal distribution? Normal distribution bell-shaped curve. This is the normal distribution, which is the bell shape. Let's say this is the 40, right? This is the assumption average age mean. Average mean. What we got? 45. This is the sample mean. Sample mean we are denoted the X bar. As we did you remember? Might be sample mean we denoted the X bar. This assumption mean mu. This is the population mean. This is the population mean. Here the difference. This is because of due to the difference due to randomness in the data. Difference due to randomness in the. Will it be fine? Yes. Now testing of hypothesis follow the 5 steps. testing of hypothesis, which is following the 5 steps. First one will make an assumption, test the null hypothesis, test the alternative. Fourth one, test statistics. That is the Z distribution basically. Z distribution nothing but normal distribution. Z distribution nothing but normal. Fifth one will be interpret the results. Testing of hypothesis following 5 steps. Make an assumption. Write the null hypothesis. Test the null hypothesis means write the null hypothesis. Write the alternative hypothesis. Test statistics. Interpret the results. Test the null hypothesis or write the null hypothesis. Both are the same. Write the null hypothesis. Write the alternative hypothesis. Make an assumption, test the null hypothesis or write the null hypothesis, test the alternative hypothesis or write the alternative hypothesis, test statistics, that is called Z distribution or normal distribution, interpret the results. Now here what we are going to do. How do we do? Let's go with a one by one. As we given a PNB National Bank CEO claims that on an average employee age is 40. That is the assumption. Make an assumption means the first step will be we need to assuming something. In our example, the assumption is PNB CEO claims that on an average employee age is 40. That is a null hypothesis means our assumption as well as sample results both are correct. That is called as the null hypothesis. Your assumption and sample results are not correct. That is called as the alternative hypothesis. How do we check whether your null hypothesis correct or wrong, or your alternate hypothesis correct or wrong? We need to test it. So how do we check? Because we need to calculate the sample mean, right? For in our case, we need to take the sample employees age and then we need to calculate the mean. How do we calculate the sample mean? Based on the Z distribution. What is the formula of Z distribution? Z is equal to x minus mu by sigma. That is the formula. And if the correct sample and correct, then we can say assumption our sample results also correct. Otherwise we can make a decision our sample is not the correct. We need to look for the alternative sample. That is the meaning of the or interpret of the results. Clear? Let me repeat the 5 steps again. Make an assumption. What do you mean by make an assumption? Our assumption, whatever some client assuming that now let's say someone said that today heavy rain is going to happen in Bangalore. That is an assumption. I claim that today is going to happen heavy rain in the Bangalore. Maybe I said this with the proper evidence, or maybe random guess I might have assumed, claimed that. As a data scientist, what you need, hey, some XYZ person said that today is going to happen heavy rain in Bangalore. We need to prove it, whether it is going to happen or not. You have taken some sample information from the various sources. You have taken some sample information. If your sample also says that today rain is going to happen in Bangalore, then whatever I assumed, whatever I claim, that is correct. Then that is called as the null hypothesis. If not correct, sample results is not matching with the assumption, whatever claimings, then it is called as the alternative. To test sample result is correct or wrong, we are going to follow the Z distribution. Z is equal to X minus mu by sigma. That is the formula of the normal distribution as we discussed in the last sessions. Interpret the results. If it is correct, we send that the sample, whatever the assumption is correct, then we need to go for the precaution. Otherwise, we need to go for the alternative. That is the results. Yes. Alternate means another sample. We need to check it. That is how we interpret the results. Clear? Now, here we have. What?
How many samples will you get?
Sample means number of record depends.
No. First time I have taken. It's not correct. Okay. Second time I have taken another sample.
You can create n number of samples. Sample with replacement we discuss. Sample without replacement. You can discuss the n number of samples. Here, what are the problems we may face while accepting the null hypothesis? There is no issue with the alternative. If your sample results are not matching with the assumption, then we can say that that is an alternative. There is no issue with the alternative sample. There is an issue with the null hypothesis. What do you mean by null hypothesis? Null hypothesis means your assumptions and sample results are correct, then we can say that it is an null hypothesis. Alright, because we accepting your assumption, you are accepting in the null hypothesis case only. In the alternate hypothesis, are we accepting the assumptions? No, we are not accepting the assumption. Whereas in the null hypothesis only, we are accepting the assumption. What are the problem we may face in the null hypothesis? What are the problems we may face in the null hypothesis? In null hypothesis, we are checking. Now, okay. Okay, perfect. Before we are discussing about these things, how do we check whether your sample is correct or not? You are saying sample results are correct assumption. Now, some cases we may take the 500 sample, more than 30. We need basically we are saying the normal distribution. The question here, your assumption and the sample results are correct. Right? If both are correct, then we can say it is a null hypothesis. Am I right? Now, I might take the 31 records. At least 30 records should be there in the sample. Right? That is the normal distribution basic case. As we discussed the basic assumption of normal distribution, it should be the bell-shaped curve. Minimum number of observation in the sample should be 30 records. Mean is equal to median is equal to mode. Perfect. I might take the 31 records. Does it follow the normal distribution? How to follow the normal? Some may take the 500 sample, some might take the 1000 sample, some might take the 1500 sample. How do you check whether your results are correct or wrong? How do you check your results are correct or wrong? Maybe in this case, as an example, we said the average is 30. Maybe some other case, whether that variable, based on the variable only we need to check. Yeah, age is on a one variable, salary is on a one variable, or some other gender is on another variable. So, does we making an assumption for a variable or a data? Sample we are getting from the variables only. Collection of variables is nothing but sample. Collection of variable data is nothing but sample. So, are we making assumption for the variables or the data? Variables we are making. Let me write down here, please. So, we are making an assumption by using the variable level. So we need to test whether our sample is correct or not. We need to test whether our sample is correct or not at variable level only. So we need to test whether our sample is correct or not at variable level only. We are making an assumption by using the variable levels. So we need to test whether our sample is correct or not at variable level means by using the variable level means by using the variables. By using the variables we can check it. Okay, now here how do we check that? Here for every data in the statistic, based on the, as we discussed very in the first session, data science means art of making decisions by using the historical data. So whether you are taking the decision, whether it is correct or wrong, based on the statistics we are making the finalizing the decision, whether decision having the correct significant or wrong. Here also, while checking whether your assumption is correct or wrong, we need to follow the probability values. What is the ideal? Whether your sample results are correct or wrong, we need to follow the probability values. The ideal range of probability values are 0 to 1. If the probability value, here probability is denoted with the P is the probability value. If the probability value towards the 1, then we can say that our assumption is our sample results are correct. Based on, again, when we check the normal distribution, we get the probability value, right? When we check the normal distribution, z is equal to x minus mu by sigma. If you look into the table, we get the probability. Normal distribution, Poisson distribution, everywhere we got the probability value. With the probability value towards the 1, then we can say that our sample results are correct. If the probability results towards the 0, then we can say that our assumptions are not correct. If the probability value towards the 0, then we can say that we can say that our sample results are not correct. In the industry, how do we denote it with the, here in the industry probability value, in the industry how does they denote it? In the industry, probability value denoted with the confidence limit. Probability value are denoted with confidence interval limits. That is again discussed with the demand alpha value, confidence interval. In industry, probabilities are denoted with the confidence interval limits, that is denoted by alpha value. Confidence interval is the denoted with the alpha value. Probability always denoted with the capital P, not the small p. Probability is always denoted with the capital P. In the industry, it is denoted with the confidence interval limit, which is the alpha value. The basic formula for the alpha is P is equal to 1 minus alpha. P is a small p. This is small p, which denotes the probability of deviation. Probability of small p is nothing but probability of deviation. Alpha is nothing but confidence interval. That is nothing but actual probability value. Actual probability value. Small p is nothing but probability of deviation. Alpha is nothing but confidence interval, that is nothing but actual probability value. Okay, let me ask any question. Guys, any questions? Any questions? Hello? Any questions?
No, Gordy.
Okay, thank you, sir. Here, so simple, let me give a small example. Let's say probability of small p is equal to 0.05. What does it mean? Small p is the 0.05. That is nothing but probability of deviation is 5% only. Probability of deviation is 5% only. Then what is the alpha value? Alpha is equal to 1 minus small p. Then alpha is equal to 1 minus 0.05. That is nothing but 95% confident. In this case, our sample results are correct or wrong? In this case, 95%, our sample results are correct or wrong? 0 to 1. 0 means 0%, 1 means 100%. Here 95%. That means our probability value is reaching towards the 1. Then we can say that our sample is correct. Our sample results are the correct. Let's say the ideal scenario in industry which accept ideal scenario in industry accepts probability value. Probability value means confidence interval should be 95% or more. Then only our assumptions and sample results are correct. Otherwise, we will go for the other samples. Otherwise, we will go for the other sample. Ideal scenario, industry acts as probability of confidence should be 95% or more. Then only our assumption and sample results are correct. That is nothing but null hypothesis correct. Otherwise, we will go for the other sample. That is nothing but alternative sample. Here in this case, that means what is the formula? P is equal to 1 minus alpha, right? Here in this case, P is equal to 1 minus alpha. What we are going to do? P is nothing but probability of deviation here. Probability of deviation. Alpha is nothing but confidence interval. This is the actual probability value. For example, your alpha, assume that first case 1, test 1, alpha value is 96%. Then what is your p value, probability of deviation? Then probability of deviation is 4%, right? That means null hypothesis correct or wrong in this case? Null hypothesis correct. Null hypothesis test 2, alpha is equal to 68%. Then probability of deviation will be, probability of deviation as per the formula is 32%. Then null hypothesis correct or wrong? Null hypothesis, reject the null hypothesis. Reject the null hypothesis. This concept extensively we are going to tomorrow onwards we are going to discuss about the algorithm. There we are going to discuss this concept for each and every variable. To eliminate a variable, we are going to use the null hypothesis correct or wrong, or assumptions correct or wrong. Based on the null hypothesis, based on the alpha value or probability deviation value, we will eliminate the variable. There we will use it. You may understand why we are discussing now. Maybe you may not understand at this point. You may understand going forward sessions definitely. This is a pure theoretical part. We are going to implement in tomorrow onwards. So this case, alpha value how much should be there minimum? Alpha value should be 95 or more. Then only we can accept the null hypothesis. Otherwise, we can reject the null hypothesis. That is nothing but alternative hypothesis only. Here in this case, what are the problems we may face while using the or while accepting the null hypothesis? Problems while accepting the null hypothesis. Problems while accepting the null hypothesis. One is type 1 error. Second one is type 2 error. First one is a type 1 error. Second one is type 2 error. First one is the type 1 error, second one is type 2 error. Type 1 means, type 1 error means, type 1 error means your assumptions and sample results are correct. Your assumption sample is correct, then what is called null hypothesis. Your assumptions and sample results are correct, then it is called as a null. Your sample and assumption results are correct, still we are rejecting the null hypothesis. Still we are rejecting the null hypothesis. Then we can say it as a null, it is a type 1 error. Why we are rejecting? Assumptions and sample results are correct, still we are rejecting the null hypothesis. Then we can say it is a type 1 error. Why we are rejecting it? The reason is because of rare events. What do you mean by rare events? We discussed about the rare events are two types of events: rare events, simple events. Sample events are rare. The outcome of the procedure that cannot be break down further. If we toss a coin, we are going to get the either head or tail. The outcome we get the head or tail. That cannot be possible to break down further. Those are called as the simple events. Rare event means the probability of those events are very, very small or minute. Those are called as the rare event. For example, winning a lottery for the first time is fair. For consecutively winning a lottery for the 20 times in a row, is it possible? No, it is not possible. Those are called as the rare event. Even if it is possible, the probability value is very, very small, which is possibly towards the 0. If the probability value is towards the 0, then we are accepting the null hypothesis or we are rejecting the null hypothesis. We are rejecting the null hypothesis because deviation value is increasing. So the alpha confidence limit is reverts towards the 0 for rare event. So that is the reason. Even if confidence limit towards the 0, we are rejecting the null hypothesis. Even if it is the sample results or assumptions are correct, still we are rejecting just because of the rare events. Let me repeat again. Type 1 error means your assumptions and sample results are correct, still we are rejecting the null hypothesis. Then we can say it is a type 1 error, because the reason is why we are rejecting the type 1 null hypothesis, even if it is true, just because of rare events. There could be a possible. What do you mean by rare events? The probability of those events are very, very small or minute. We cannot consider those probability value. That means those probability value which is close to 0. As we mentioned that the probability values are close to 0, then we are rejecting the null hypothesis, even if it is the true. Those kind of errors are called as the type 1 error. Maybe let me give you one small example, which is a really happened incident. One pregnant woman went to the hospital. She knows that she is pregnant, and there is a medicine. Maybe at the moment of the BP, checking the BP, all this, the scans, various scans are there, I mean, like ultra scan or whatever the early pregnancy scan test, whatever the scans are. Due to BPness, it will check the micro level analysis. What the BP high, it says that just because of the probability statistic value, system says that she is not a pregnant. She is not a pregnant. But then what kind of error it is? She is a pregnant. But because of high BP blood pressure in that moment, the system calculates blood pressure. If the blood pressure is high in that moment, it indicates that she is not a pregnant. That means the probability value which is considering here very minute. Based on those minute value, ideally we cannot make the decision. But what the system did, based on those probability values, system make the decision. So we need to careful while making the decisions. Clear? Next, what does the type 2 error? Is everyone is clear? Type 1 error? Guys, is everyone is clear? Type 1 error? Type 2 error. That your assumption and sample results are not correct. Still, we are accepting the null hypothesis here. Still, we are accepting the null hypothesis. Still, we are accepting the your assumptions and sample results are not correct. Still, we are accepting the null hypothesis because of biased data. Maybe here what is happening, type 2 error means your assumption and sample results are not correct. Then what does it mean? Ideally, alternative, we are not going to the alternative. Alternative means your sample is not correct, then stop it the your assumption. That is the meaning. But we are not going there. What we are doing here in this case, your assumptions and sample results are not correct. Still, we are saying that null hypothesis true. The reason here, maybe we are taking the biased data. We are picking the random sampling, as we said, there could be a possibility sometime happen biased data also. So we are checking the biased data. Let's say I have taken the employee's age only near 40 in the organization, as we discussed the PNB. Organization employee's age range is 21 to 58, somewhere like that. Just I randomly take the 40, then my average will be 40 only. Maybe I have taken the 50 years above. Then my assumption may not be the correct, right? Then what we need to do, we say that maybe we have taken the wrong sample. Let's take the another sample. That is the meaning of the type 2 error. Type 2 means generally alternative hypothesis, null hypothesis, alternate. Null hypothesis means your assumption and sample results are correct. That is the meaning of null hypothesis. Your assumption and sample results are not correct. That means it is the alternative. Alternate means our test we are going to stop it there only. We are not going further. Here what we are doing, your assumption and sample results are not correct. Still we are accepting the test. Just because there could be a possibility we might have considered the biased data. Let's take the another set of sample data, check it. Even if you are failing there also, then we can say that it is an alternate hypothesis, then we can stop it. Like this is the meaning of the type 2 error. This is the meaning of the type 2 error. Type 2 error because of biased data. In interview point of also, there's some, most of the time they might ask a question, what do you mean by type 1 and what do you mean by type 1 and type 2 error? Type 1 means your assumptions, your null hypothesis is true, still we are rejecting the sample. That is called as the type 1 error. Type, because of rare events. Type 2 error means your null hypothesis wrong, still we are accepting the sample. That is called as the type 2 error, just because of the bias data.